Yes, I think we can start with the explanation of this biweekly contest. So first, let me know how many of you got the error. So when I was registering for this contest, I couldn't able to register for this contest, right? I couldn't able to register for this contest. It asked me for verifying the mobile number, but it couldn't. The lead code couldn't give me the mail, send me the mail. And after not being available, I got the mail, but it has expired. It has been expired. So I think we are good to go. Provide a better. Okay. Okay. So we are. I think we can start with the first problem in today's biweekly contest. 181. Right. Let us see what is given in the problem. Valid digit number. You are given an integer n and a digit x. A number is considered valid if I haven't solved this yet because I couldn't register for this contest. It gave me an error. So now let us see what how we can solve this problem. A number is considered valid if it contains at least one occurrence of digit x and it does not start with digit x, right? So it should have at least one occurrence and it should not be having that digit should not be at the first place of the given integer n. Return true if n is valid, otherwise return false. This is a simple problem. 101. Only if you know the standard template library, you can solve this in 1 minute. N is equal to 1 minute. N is equal to 101 and the digit x we are given with is 0. Now, the first one, the first character is not equal to 0. I have two characters. I have the other two characters or the digits. Now, from this, even if I have one digit which is equal to x, which is equal to x, then return true. Then return true. I'm saying this as a character. Why? Because I want to change this to a string, right? So if I change that to a string, then it would be easier. Then I'll be searching for a digit x from the index 1, right? So let us see what are the constants. I have seen the first example, and also I have seen the description. Let us look at the constants. So the constants are n can be till 1 is 5, right? And the x can be 0 to 9 inclusive. So what I'm thinking here is convert the convert the just a minute. Hello, bro. Just came here. Couldn't do the last two questions. Yeah, bro. How many of you got it to register for the contest even? I couldn't register for the contest, right? I saw the problems. I saw the problems from my friend's laptop, but I couldn't register for this contest. How many of you have registered and gave this contest? So while I was registering for this contest, it asked me to verify my mobile number. So it said it will be giving me a mail which has a confirmation code to verify my email ID. But I didn't get the verification code. So that's why I couldn't register for this contest even. Did you register for this contest? Please let me know. So the convert the integer n to a string, or without even converting, you can also get the reminder by with a for loop by but I prefer to convert it to a string so that with only one for loop it could be easier, right? We'll also look at that approach, but let us see. Can we solve this using, converting it into the string? So to convert the integer n to a string, then I start for both today and tomorrow. But for tomorrow, I had to verify through OTP, but I opted for okay, WhatsApp. Okay, good, bro. You made a good decision by registering for today and tomorrow's contest. All the best for the tomorrow's contest, bro. And let me know what is your rank today in the ranking. So let us go to the problem. Okay, right. So I'm just this is an easy problem. If you are a speed typer, if you can type speedily, you can just solve this in 1 minute. If you have solved more than like if you knew DSA from 1 year, you can solve this in just 1 minute, right? So this was quite easy. Convert the integer n to a string, then check from index one from index one if there is a digit equal to x Let me tell you, for I is equal to 1, I is less than n. What is n here? No, I cannot use a n here. Why? Because we are given with the function with n and x. So let me say that as s dot size. We are converting the integer n to a string s, right? So I'll just take it as I is equal to 1, I is less than s dot size, I plus plus. Now, if this character or the number is equal to the digit is equal to x, so s of I, if it is equal to no, if you see here, s of I is still a character. I need to make it into a number. Then only I can make sure I would compare it with the digit x, right? So s of I minus 0 will give me a number which I'll compare it with the x. Then if it is true, so if it is true, then we got it like the the two things which they have mentioned right here. X should be present at least once, at least once, and X should not be at the starting position, at the first position or index 0, first position or index 0, right? So if s of I minus 0 is equal to x, then return true. If not, I'll check everything and I would return false there itself. So let us code this. Firstly, let's take a string as is equal to to string string n. Now, at around 7 900, my current rating character is like this. Total 7 contests given 15 is okay, 1500, 1400, 14, 14, 15, 15, 15. But now I think it will decrease. Yeah. So many of the people have solved. I guess many of the people were easy and was able to solve the first two problems. So if you have even solved it, you have to solve it. Might be under like it's not possible, but you need to be a good at typing. Not typing actually. You need to be good at logic first. Typing it doesn't matter, right? If you got the logic in just 1 minute, and if it takes you to uh, give the whole code for 2 minutes, then it would be three, or at least like in 15 minutes you need to be have solved the first two problems, right? So I think then it would be a good one, but there are many people, this is competition, right? There are many people who got to solve this in less than, you know, in less minutes, right? So I think, I think, I think we also have to be more into third and fourth minutes, right? It would be greedy, it would be DT, or it would be graphs, but these all are the hardest uh, things, right? Okay, okay. In second question, Sandeep Kumar Radhakrishna. Okay, bro. Yeah, that's a good recommendation. You're recommending for the YouTube live stream, or you are recommending for the people who are attending the contest? In second question, I use binary search for finding the peak element. Okay, that's good one, bro. Sandeep Kumar Tiwari. But the other four are not able to solve it. Okay, let us see what. Let us discuss about the third and fourth. But second question tricked me, and I got the penalty because I forgot to put data type for assign. Okay, to be long instead of int. I made this huge silly mistake. Hello, Sandeep Kumar, bro. Thank you for attending the live session. So we'll be solving the first and second problems in firstly. So I got this string for int I is equal to 1, I is less than s dot size I plus plus. So if s of I minus 0, if it is equal to x, then return true. If not, will return false. Let me know why for the second problem you have used a binary search. Someone said that they have used a binary search. Okay, we got a wrong answer. 232 x is equal to 2 I is less than s dot size. I is equal to 1 I is less than s dot size. Okay, s of I minus 0. Let me put this in brackets. No, we got a wrong answer again. False, but it expected was false. The number starts with two, which okay. If s of 0 is equal to uh, s of 0 minus 0 is equal to x, then we'll return false. So there is a subtle error which I have done. So the first character should not be should not be x, right? So the first number or the first digit should not be x. Let's go with this one. Compare sums of bitonic parts, right? So let me. Okay, you are given a bitonic array nums of length n. Split the array into two parts. Ascending part from index 0 to the peak element inclusive. Descending part from the peak element to index n minus 1 inclusive. In second, no need to do BS cause it was strictly increasing and then strictly decreasing. Just use simple. Yeah, I also thought about the same thing. I think your name is Akash, right? Just a winner. I know. Sorry if I made a mistake, if I forgot, but I remember your name as Akash. So, descending part from the peak element to index n minus 1. Okay. The peak element belongs to both parts. Okay, return. So peak element will be on the both the parts. 0 if the sum of ascending part is greater, 1 if sum of descending part is greater, minus 1 if both sums are equal. Note. A biatonic array is an array that is strictly increasing up to a single peak element and then strictly decreasing. Okay, an array is said to be strictly increasing if each element is strictly greater than its previous one. Uh, did you create a hash map of mine in your brain or what? How did you remember? That's a good, great comment, Akash bro. No hash map needed, right? So, okay, I remember names clearly. Okay, right? An array is said to be strictly decreasing if each element is strictly small. I think you already knew what is strictly increasing and strictly decreasing, right? Okay. Now let us see with 1, 3, 2, 1. 1 and 3. These are strictly increasing. And then 3 to 1. These are strictly decreasing, right? 1 and 3 are strictly increasing. 3 to 1 are strictly decreasing, right? So I think we can look at the second example. 2, 4, 5 and 5, 2, right? 1 to 4 and then a 3. And we can write these conditions when we need to return 0, 1 or minus 1. So the first thing in the second problem is this. So there is a peak element, there will be a peak element, and there is this array. I need to find the peak element. Then I'll find this sum and I'll find this sum. Then as Akash bro, as you said, there will be ascending sum and also descending sum. And thank you for saying me there is a runtime error for not using long, right? So it will be helpful for me. I did. This is the first time I am giving this. There are no submissions of this problem. I'm seeing this problem, right? Okay. I'm solving this for the first time. So I need a peak. So how do I get this as the peak? So 1, 3, 5, 7, 10. Then I would be having like 3, 2, and then 1. So when I got at 3, excuse me, when I got at 3 from 7 and then 10, from 7 and then 10, array, sorry, nums of I is greater than nums of I minus 1. The nums of I, the current element is greater than the previous element, right? Now, when I come to here, 3 and then 10, nums of I here is lesser than nums of I minus 1. There will be only one element like this. One element from this left side, right? So when I got that, that's where my peak element is present. So to find peak index, let us take it as index, right? So for I is equal to 0, I is less than n, I plus plus. If nums of I, if it is lesser than nums of I minus 1, then I'll make the peak as I minus 1, right? The peak element as I minus 1. But if you see, I'm checking I minus 1 when I is equal to 0. It's not possible. So let's say I is equal to 1. Now I got the peak element, then I will break there itself. Why? Because if I say nums of I is lesser than nums of I minus 1, the current element is lesser than the previous element, then I would get this element as the peak. In fourth one, I could have used brute force, but I then stopped doing it because I thought it will give me runtime error. But my feeling was like it can only be solved using segment tree algorithm. Can you please tell? Yeah, segment tree. I think I need to make some work on the segment tree and Fenwick tree, and there are some algorithms I need to work on. Infinity segment. Yeah. So let us discuss about the fourth problem, right? So we'll go to the problem once we complete the second problem. We'll go to the third and fourth. So I'll take the ascending sum. Ascending sum is equal to 0. Descending sum is equal to 0. Now again for I is equal to 0, I is less than or equal to peak I plus plus. Then I'll have ascending sum plus is equal to nums of I. Then for I is equal to peak, I is less than n, I plus plus. Descending sum plus is equal to nums of I. Right? So let us go here and let's write int n is equal to nums dot size. No, I is equal to 1, I is less than n. I am finding for the peak if nums of I is lesser than nums of I minus 1, then we need to break. But before breaking, let the peak index is equal to I minus 1, right? So I need to initialize int peak is equal to minus 1. Okay. Is equal to minus 1. Now, for int I is equal to 0, I is less than or equal to peak I plus plus ascending sum. We need to also initialize it, nums of I. Then the same thing here, where we have this as n, then we have it as peak, then we have descending sum, right? So long ascending sum is equal to 0, descending sum is equal to 0. Right? Now we have these conditions. So if ascending sum is if the ascending part is greater than descending sum, it's des sum. If it is greater than, we will return 0. Else if descending part is greater, if descending sum is greater than ascending sum, then we'll return, else we'll return minus 1. That's it, I think. Let us, okay, let me submit it and okay, let's go to the third problem. Right, so we'll just return a count connected sub. Okay, this is also a hard problem. Right, count connected subgraphs with even node sum. You're given an undirected graph with n nodes labeled from 0 to n minus 1. So we are given with an undirected graph. So there are bool bool e and c peak variable. Okay, okay. I didn't get you, Akash. By using a bool e and c peak variable. Okay. You are given an undirected graph with n. Okay. Node I has a value of nums I, which is either 0 or 1. Okay. The edges of the graphs are given by 2D array edges, where edges of I is dy vi represents an edge between node ui and vi. For a non-empty subset S of nodes in the graph, we consider the induced subgraph of S generated as follows. We keep only the nodes in S. We keep only the edges whose two endpoints are both in S. Okay. Return an integer representing the number of non-empty subsets S of nodes in the graph such that the induced subgraph of S is connected. The sum of node values in S should be even. So that's the point. The first thing we need to have, so the previous chart is the continuation of the previous problem. Okay. So I think it's the first problem I think you're talking about. But let's talk about the third problem, which is quite interesting. So we are given with a graph. We have some edges here, right? Okay. Now, the edges of the graphs are okay. We have connections. Okay, there are some connections. For a non-empty subset S of nodes in the graph, we consider the induced subgraph of S generated as follows. Okay, we also have a subgraph. We keep only the nodes in S. We keep only the edges whose two endpoints are both in S. Okay, let us see what's happening. I am quite confused with this. We keep only the nodes in S. We keep only the edges whose two endpoints are both in S. In an integer representing the number of non-empty subset S of nodes in the graph such that the induced subgraph of S is connected. Okay, we keep only the nodes, only the edges with two endpoints. Okay, okay, the induced subgraph of S is connected. Sum of node values in S is even. Okay, let me tell you, I couldn't solve that question, but like I thought of using connected component or disjoint set or set union. Okay. Let us see 101. Nums is equal to 101. So 0, 1, and then 2. Edges is equal to 0, 1, 1, 2. Let us have this. Let us see. I have three nodes 0, 1, and then 2. Now I have 1, 0, 1. Nums is equal to 101. I have 01 as a connection and 12 as a connection. Now there is an output of 2. That means I'm quite having a. Okay, let us see by looking at the examples. I think we need a greater example, but it doesn't have any greater examples. All edges are distinct. Okay, edges of I. So all edges are distinct. Okay, represents edge. Okay. For a node, for a non-empty subset S of nodes in the graph, we consider. So I think it might be having a disjoint set union, something like that. Okay, we consider the induced subgraph of S generated as follows. We keep only the nodes in S. We keep only the edges whose two endpoints are both in S. Okay. Non-empty subset S of nodes in the graph consider the induced subgraph of S generated. Induced, let me say that as induced subgraph S as follows. With only the nodes in S. Nodes in S. We keep only the edges whose two endpoints, edges whose endpoints, whose endpoints are in S. Let me tell you, if there is 3 and then 4, right? Now S is having 1 and then 2, right? Now, induced subgraph will have nodes in S. I think this problem description can be quite misleading. They could have simply said find subsets of graph where all nodes in that subset are connected and total sum of their node value is even. Okay. Are you sure, Akash? Is that a clear description? I think there is no count connected subgraph with even node sum. Let me copy it, go to the problems, count. Okay. This one, right? 3910. Okay, let us go to dis discussions. The number of cheaters on this are okay. 58% acceptance rate. No, no way there will be 58% acceptance. Gang, congrats me. This question is contributed by me. And they choose it. Let's go. Thanks, lead code. You made my day. What? This two-step verification got me out of the contest. Okay. And one verification issues. Yes, look, I couldn't even upload you. It's just simple recursion plus backtracking due to loose concepts. No fancy approach. That's why this third question, not fourth one, as required was to do backtracking in this. I tried backtracking plus auto accept either DFS or BFS. Canvas was news. आज इतने कम लोग क्यों दे रहा है कॉन्टेस्ट सबका सिलेक्शन हो गया okay not that hard okay but they I think there are less brute force okay I think my approach is really bad. Mm, I think there is all just are tested. I think yeah, I think it's okay. They could have also the subsets of graphs where all nodes in that subset are like connected and total sum of their node value is even. Okay. So you are saying that subset of these graphs where the sum is even. How many how many subsets are there in these graphs where the sum is even? Right. I think I think DP I think there will be no DP like this, right? I don't think of any DP here. How can we go with this? I think if you have four, then go with three again, right? Might be going with three, and then if I have another like seven, so so to make two to get an even, we need two evens and two odds, right? Two evens or two odds. That's it. Nothing much. So so if I start with every number subset, I think it needs to be connected, but it's quite hectic. Let me go with the topics. Okay, enumerate all subsets with bit mass. Can we enumerate with bit mass? Let us. Okay, okay, I got an idea here. So imagine we are having. I think like if we have multiple components, then the answer will be like so component one plus answer of component two. Okay, answer of component three. Okay, let us see. Okay, but if you think, let me tell you one thing. Like imagine I have one, three, two. Okay, zero, one, two, three, four, five. Now there will be subsets. There I can easily generate subsets. But the problem is, how do you make sure the subsets are connected? That's where I am getting a doubt that are this subset is connected or not. Or just I zero or one. And why did they give us as zero or one? Okay. We consider the induced subgraph of S generator. We keep only the nodes and we keep a value of nums of I. Okay, node I has a value of nums I, which is either 0 or 1. Okay, the edges of the graph be given by, so I was thinking of like iterating through edges and then distress union approach. Okay, but I think where we can use the disjoint set union might be like when we need to find the parent of the parent of the node. But I think there is no need of using uh, finding the parent of the node which we are, right? I think there is some BFS or DFS approach. Okay, but let us see. Let me tell you one thing. Let me tell you this simply. It's one, and then I have a zero, and then I have a one, and then I have a zero, and then one, and then zero, and then one, and then one, then a zero. Let me tell you here. I think okay. Let me tell you. This is like having some uh, indices I 0, 1, 2, 3, 4, 5, 6, 7, 8. Let me tell you, I'll be having a visited, okay, sorry, a visited array which will be having 0, 1, 2, 3, 4, 5, 6, 7, and then 8. Now let me tell you, I haven't looked into 0. So what I would do, I'll go to this index where I have a 0. Now it is having 1 as value. If you see 1 as value, then I'll mark it as I'll mark it as visited. But before that, here my sum will be 1, right? So 0 is visited. Now I'll go and see what are all the adjacent nodes where I have, right? So I have an adjacent node which is of 2, right? So while I am creating these nodes or the graphs, I would create it with indices, right? That's what they give. 0 and 1, 1 and 2. I would create it with indices. Now what I I will do is every time I need to go and check with nums of I, where is this? So okay, let me write it again. Let me write it again. Let me rewrite it. So instead I can just take this, make a copy of this. Okay, this 0. Then I need to remove this one. There is this hectic. Like exploring the subsets using DFS, like with maintaining the previous sum and increasing the answer gradually. Yes, yes, bro. I'm thinking of it. I don't know whether I'm correct or wrong, but let me try it first. So I might get a wrong answer, but let me try it first. I hope you got it. So 0, 0, 2, 1, 3, 4, 4, 8, 5, 6, and then 7. I have the values as 0, sorry, oh, sorry. I have the values as 1, 0, 1, 0. Yes, Akash bro, you're right about the thing, but let me go with the approach. I might get it wrong also, but let us try. Now I'm going with index 0. So there will be this listed array 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I have at index 0, it is listed and the sum which I have here is 1. Now is it, equal to, is it even? No, right? Now let me go to the adjacent node where I have 0. So 1 plus 0 is still, let me write it over. 1 plus 0 is still sum as 1, right? Now I'll go here. Now I got 2. Now, if you see, if every time I get the sum as even, I would mark the count. I'll just increment the count, right? Now, 1 and 0, 1, 0, 1, 2, 3 are already listed. Now, I'll go here. I got 0. So 2 plus 0 is still 2. But 3 is already listed. Then I would go backtracking. Then I would go to 4, right? So when I go to 4, the sum is still 0. Sum is still 2. 2 plus 0 is still 2, right? So let me use 4. Now from 4, I would go to 8, where I have a 1. Then the sum would become 3, right? But 8 is already listed. Then I would go backtrack from 4. 4 is already listed. Then go to the next adjacent node, which is 5. So 5 is having 0. So 3 plus 0 is still 3. No need to up, upgrade our count, right? Now, okay. Now let's go with one thing. One thing. Let's wait for one time. Every time if you see, let me backtrack. Let me stop here. 0, 1, and 2 are listed. So I have the sum as 1 plus 1, which is 2. Now, let me stop here. Imagine this as your subset. Now, what are the elements here? 1 and 1, 0 and 0, which is even, right? So why I am not counting it? That's a mistake, right? Let me tell you, let me go back here. So from 1, I would go to 3, which is 0. So 2 plus 0 is still 2, which is even. So this is also valid, right? Now the count would become 2. Now let me track back to here where I have 1 as node, but before let me mark 3 as visited. Now I have 1. From 1, I'll go to 4, right? So 4, if I add 0, the sum will be 2 itself, but the count will be incremented. Now, from 4, 4 is already listed, then I can go to 8. I can go to 8. So I would go to 8 and mark it as listed, and sum is now 3. Will I increment the count? No. Why? Because the subset which I have is having a sum of 1, 2, and 3, which is not even. So that's why I would not increment the count. But while I backtrack, I need to minus this 1 from the sum. So I would make it as 2. That's it. That's a great backtracking problem, right? So I would go to 2. Now, uh, now let us see. I also have a doubt. Why I cannot, I think I would not get this one. So this is also a subset, right? Let us check whether we are going in the right direction or not. So I would do, then I would go to this. So 8 is already listed, 4 is already listed, 5. is already visited. Now 2 plus 0 is 2, 5 is already visited. So here the sum is even. Now I would increment the count to 4, right? Now from 5, I can go to 7, right? So if I go to 7, the sum will be 3. Now then, 7 is already listed, so backtrack. I would go to 5 and also decrement the sum to 2. Then I would go to 6, then it is marked as listed. Then 6 is having a sum, uh, a digit of 1, so 2 plus 1 is 3, which is not even, so the count still remains 4, right? Now, I have some doubt. Let me tell you what my doubt is. Okay, I have nums dot length is 13. So 13, if I 13s is 169, which is quite less. But I think backtracking would give me more than big of n square. It might be big of n cube, but let us see. So if you clearly see, I'm saying the count as 4 only if I start with 0. Let me save another thing. What if I started with this index 1? Then I would have this subset. But I have already have counted this subset previously when I started with 0 here, right? There is this error. Let us see. I already have this into the count, right? Okay. There might be another way we can solve something, but for a separate check whether the include is connected using DFS or BFS. Okay, okay, that's a good one, bro. The hints are quite useful. Okay, that's the first time in a hard problem I have got the hints useful. So they are just saying that use this bit mask, use bit mask, and get all the subsets. If this check if the subset is connected. If so, check sum. If the sum is even, then increment the count, else no need to do anything. If so, check sum. If the subset is connected, then check the sum. These two questions are good, right? Yeah, bro. The third problem, I just saw the third problem, but I don't know what to do with the fourth one. I don't know. I didn't see that. Is it the continuation of the? No, okay, it's smallest. But let us see. Let us go Akash. Oh yes, these are quite intuitive. We need to we need to solve it. I didn't even thought about the bit mask thing and also getting all the subset. That's why I think always say that to look at the constraints, right? So how do I generate all the subsets? That's the first one. How do I generate all the subset? Let me go to the question which I have. So, okay, let me go to the question where generate all the subsets of an array. Okay, Let me get the code. So in nums, I can get all the, okay, so push back temp. I have these subsets. So vector of vector in subsets, because I think this manipulation is enough. We can use this I is equal to 1 to I is less than power of 2 command. Let me tell you how we can get the subsets. Let me tell you one thing. Imagine, imagine I have 0, 1, and then 2. So to take this, I would have, I would go with 0. I'd go to 1, 2, 3, 4, 5, 6, 7. I'll tell you what is this. How do I represent 0? 0, 0, 0. How do I represent 1, 0, 0, 1? 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. If you see, if you see here, 0, 0, 0. Take none. I'm not taking anything, right? So that would be empty array. From 0, 1, 2, or let me tell you 1, 2, 3. It would be easier for you. How I can get subsets 1, 2, and then 3, right? So it is an empty. Is this kind of brute force? No, bro. It is just, you know, it is just like generating the subsets, right? Let me tell you. Here I'll have it is 1, right? Where I have 1 at 3, where I have 1 at 2, where I have 1 and then 1, 2 and 3, where I have 1 at 1. I got all the subsets if you see 1 comma 3, then 1 comma 2, then 1 comma 2 comma 3. That's how I get all for every nums array. No, Akash bro, it is something like generate. It is how can I tell you is like, let me tell you with another example. Imagine 1, 2, 3, 4 is given, then 0, there will be from 0 to, what is 2 power 3? 2 power 3 is 2 into 2 into 2, which is 2 to 4 to 8. It is nothing but 8 minus 1, which is 7, right? So 7, I would represent 7 like this, right? So that's how I would get all these, every number. If I have a 1, I would get the element at that uh, index, right? So, okay, I hope you got it. If you have any doubts, you can just message me in LinkedIn. I'll be solving your doubts. So, vector of int subsets. So, wherever I have the subsets, I'll be having, instead of them, I will be creating subset, right? I have the subsets now, where n is equal to int n is equal to nums dot size. I have all the subsets now. Okay. Now I have the subsets. I need to know whether they are connected or not, right? Is connected. There is also a problem. Every time this connected graph lead code, no, it's not even in a hard problem. Okay, let us see. Let's see if a subset is connected or not. Um, let me let me do a DFS or BFS so that I can easily mark every element which I have visited as true. Right? So what I would do is for auto subset in subsets if connected, the subset is connected, then I would get the sum, right? Then I would just get the sum. Now what I am having here is I'm having nums of j. Instead I just need j, right? I'm just having the indices now. Have the indices. If the subset is connected, int sum is equal to 0 for auto x in subset, sum plus is equal to nums of x. Now if sum mod 2 is equal to 0, then just increment the count. Int count is equal to 0. Return count at the end. Now I need to write the I have the indices, right? So count of subset with graph. So this graph will be vector of int graph for auto edge in edges, graph of edge of 0 dot pushback edge of 1. The same thing. It is 0 and then 1. Now bool connected of vector of int, not it will be changing, right? Not the same thing. Subset and then graph vector of int graph, right? Right, graph. Now in this I'll create visited array. Visited, okay. If anything is unvisited, then we would mark it as so. So let me take another vector of int where I have visited array, right? So vector of int visited for, let me tell you, I have this subset, right? I have this graph, I have this subset, I have the graph, and I also have the subset. How do I get through the BFS? So we'll be having a queue of in queue. Now queue dot subset. I have this indices, right? Have the indices. Okay. Q dot push subset of 0. Listed dot pushback subset of 0 while this queue while this while this queue is not empty, then int node is equal to q dot front q dot pop, then for auto neighbor in graph of node. So every neighbor if it is not listed. Now I need to check, I think. Now let us take it as set instead of pushback insert. If visited of neighbor is not a single visitor and then what I would do if it is not visited, then give dot push the neighbor push the neighbor. Then also have this as visited. So visited dot insert the neighbor. Is there anything which I have missed? Nothing. Okay. Vector of int visited array visited dot begin visited dot end sort subset dot begin subset dot end return if subset is equal to step array. Okay, let us check it runs or not. Compile error. I think we got something visited dot find neighbor. Got some mistake here. Any idea of who have solved this? Right? I have already solved this. Got carry runtime instance binding to pointer of type vector int undefined behavior. If anyone is having any doubt till now, we got an error while referencing vector of int. Okay. I think there is an error. Listed array of listed dot begin. Even some. How can we solve this actually? This is okay. So if you see graph of edge of zero is where I'm getting an error. Okay, let me Okay. Set of key is only one. Okay. Visited dot find neighbor. Okay, if it is visited, if it is if it is contained or if it is found, then we are visiting it again. No, it's not like, yeah, that's the error. Okay, okay, visited dot. Let me tell you one thing. Imagine, imagine we are having the components like one, two, and then three, and I have a four. Now, the subset is having one, two, three, and then four. Now, what I am saying, neighbor in graph of node if visited. No, I think there is an error here. How can the I think there is response. If I am going, is this okay? Let me tell you one thing here. Imagine, like I have one. Uh, it is not present in the subset. Even then, our BFS goes there, right? So I need a check here only if the neighbor is in the subset, right? That's why, uh, let me tell you, if I have 1, 2, 3, and this 3 is having 4 and 6, and I have a 5 here. Now the subset is 1, 2, 5, and then 3. Now when I get to 3, so I get to 1, then I go to 2, and then I go to 5, and then I go to 3. But I have this 4, I have this 6, but they are not present in the subset. So I also need to check whether the neighbor is present in the subset or not. So set of int subset set, right, which contains subset dot begin subset dot end. So if subset set dot count the neighbor and it is not listed. Okay, yeah, I hope it gets accepted. So it is quite less. But I think the fourth problem might goes with you are given an array. It is an array nums where nums is strictly increasing. Okay. You are also given a 2D integer array queries where queries of I is equal to LIRIKI. For each query, consider the subarray nums Li. If it is like this, we need to have a sequence of numbers, a subarray, and we need another query or k which is having with us. So it is definitely a what is segmentary problem, right? Consider the subarray nums from the infinite sequence of all possible integers to the infinite from possible even integers. You know all elements that appear in the subarray nums Li to R. Okay. Find the kith smallest integer remaining in the sequence after the removals. Okay. So I think this needs to be done again tomorrow while we discuss if the weekly contest. So for today it is just here till here. So if you have any doubts, please let me know. The live chat, we're gonna end this live session in just 5 minutes. So thank you for everyone who have attended my live session. Sorry everyone for not giving you the fourth problems explanation, but due to the time constraints I couldn't give you. So thank you everyone for watching this live stream. We're gonna end this live session just for a minute. So thank you everyone for joining this live stream.